Hello guys, today I'm going to show you how to create simple but pretty attractive effects of fire that we will use with the Fireplace, and we will make it with Niagara. Right now you can see the material for the fire base. Actually it's noise that is animated on the UV from bottom to top. We here use noise node instead of using texture, because the results from the noise node are always unpredictable, so the tiling looks actually more realistic. And to make noise node work with the panner, we need to use a pen node with 0 attribute and apply it all to position. We can also go with the second variation. It's break out floor to components and use make floor 3. Then we need to combine everything like this, and this layout will also work. Here I also use pen node with 2 attributes to have animating from bottom to top on my V channel or Y axis. Next, this variation is actually the mask for overall flame shape. It's a simple circle but with the different tiling. So if we look at the preview, we will see that we actually have the half of our circle. Let's wait for shader to compile. And this layout is for creating the gradient on the G channel or our V channel, to actually have the line at which starts our flame. So if you look at the preview, you'll actually see the gradient divided by 2 sides. Next, applying everything together will actually result as the flames going from the bottom to top. Let's wait a little bit. As for the noise, you actually can't modify the attributes here from the material instance, but it's not a big deal. The values you see, it's my own choice. I chose them to have the results I want. Make sure that when you select and change scale, the lower values are for bigger chunk and the higher values are for smaller chunks. It means that if we have, for instance, 30 instead of 3, our noise will look different. There will be a lot of small chunks there. Let's wait. Like this. And actually it looks like some kind of matrix code. Also, the function and levels is up to you to decide. As you can see from the tooltip, lower values are for little detail, but it's very fast in computation. The higher, the more details, but more instructions. Right now, I have 110 instructions in the base pixel shader, and it's actually good in my opinion. Also, make sure that blend mode on your material is set to masked and shading model is set to unlit. Now scroll down and select checkbox Niagara sprites. Now look at my layout, so you can copy the flow and achieve the same results. We also use particle color here. We multiply it with our computations here. The color here and the results here will combine, and on the bottom our fire or our flame will look brighter, and on the top where it disappears it will look more darker, so the result will be more realistic. The same is for alpha channel, so to control the opacity mask. Let's actually change back to 3 here, and we can continue with our smoke material. As for the smoke material, the customization is pretty much similar to our material of fire, yet it has some changes. Blend mode is set to translucent, shading mode unlit, two-sided selected also. Next, make sure to uncheck apply fogging and select Niagara sprites. Here we have also noise, but with different values, and as you can see here, right before our noise we have multiply, but with particle random value. So we can go without using any flip books of smoke with different shapes of our smoke here, and the result will actually look pretty much natural and attractive. So it's up to you to decide to use flipbooks or not. This way is the way I like most. But actually you can't see anything on the preview here because this value right now is null. It doesn't exist. So we can uncheck it and see how it will look just without this variation. Also, radial gradient exponential with the default values. So our noise will be a little bit in a circle. And also multiply nodes here and here with the RGB of particle color and alpha channel to control opacity and our color. And as you can see on the preview, we have some smoke. This result is not the same that we will achieve when we play, because this node will actually add some randomness. So let's connect those nodes together and continue. Look one more time at everything, so you can copy that, and we will proceed. I have created two material instances, one for fire and one for smoke, so I can change the values that we have as the parameters. The gradient height, gradient depth, speed for our material of fire, and speed for our material of smoke. The material can be much more complex, so just the basic implementation. So using material instances is pretty much wise choice if we won't have some different variations for different effects of fire. Now let's talk about our Niagara emitters. As you can see, here I have 3 emitters and 1 system, Niagara system of fire. Our Niagara system will use Niagara emitter of fire, Niagara emitter of smoke, and also Niagara emitter of embers. Let's begin with Niagara emitter of fire. It's the CPU emitter with the local space checkbox selected. Also it's infinite, and we will control it with our blueprint. Spawn rate is small, actually is 3. Next, initialize particle. The lifetime is set between these two attributes. We also have some basic color, just for the preview cases. In our Niagara system, we will actually have user parameters for each element we need to control with our blueprint. You can actually create all of these emitters as templates, but in the system that consists of these emitters, you can go with some different logic to change these emitters, these templates. Also, I have some custom attributes. It's sprite alignment and sprite facing. Because my fireplace in my scene is actually have rotation on 90 degrees on the z-axis, I need my emitter actually to follow the same direction as the forward vector of my fireplace. For this, I use sprite facing mode with 1 on x-axis and 0 on the 2 left axes. Also, sprite alignment is set to 1 on z-axis, so it's always looking upwards. And to add these custom attributes, you just need to select particle spawn and look for set new or existing parameter directly. like this. And then on your right side of the screen, you need to press on the cross sign and select Create New Parameter. Sprite Facing or Sprite Alignment. That's so simple. Next, sprite size is uniform. I'm sorry. It's the default parameter attribute when I can actually change the size on both axes independently. Actually, 1 unit is for 1 unit in the world, so 50 by 50, it means 50 centimeters by 50 centimeters, or half of a meter. Let's go to scale color, and as you can see, on scale alpha I have the custom attribute. It's float from curve. By telling you that I use custom attribute, I mean that it's not the original. The original is the basic float, and to change it, you need to expand this category and select float from curve. So, for all of my points here, I have auto alignment on my tangents, so the shape is smooth. Also, the scale set to 2. It means that from 0 to 1, it's the representation of the percentage, and multiplying it by some values here, my values are also be adjusted. I need this kind of curve to have the proper visual feedback when the fire slowly starts and slowly ends. So it won't pop up spontaneously. As for sprite renderer, in the alignment and facing mode, I have custom alignment and custom facing vector, so the attributes I set here in particle spawn will have full impact. And I also have light renderer with the color add that's pretty much similar but to the default color here, yet it's a little bit higher, only by 10 times, and this will add some cozy visual feedback, so our fireplace will be lit from inside. And actually, it's all for the Niagara emitter of fire, and we can continue with the two left, the embers and smoke. So, Niagara emitter of embers. It's GPU emitter, but you can go with the CPU. That depends actually on whether you need light renderer on your sparks. And if you use the GPU emitter, you actually need to set fixed bounds for your sparks, so they won't pop up when the camera angle is changing. Also make sure that you have selected local space. As for the spawn rate, it's 10 here. Emitter state has loop delay and delay on first loop only checked. We need this set up so when we start our fire, first one will be the flames, and smoke and embers need to be delayed to have the proper visual realistic feedback. Only after we have flame we actually need to show our embers and our smoke. And also loop behavior is set to infinite. Here the sphere location, the radius is 25 as our main fire emitter. Sprite size is 50, so for sphere location the radius is 25 and together the diameter is 50. And hemisphere on that axis is actually checked. So we have only upper sides of our sphere. For the initialized particle node, the lifetime is uniform range float with two different values. The color is the same as our fire main color, but actually it's for the preview purposes. As our fire and smoke, there are some user parameters that we actually have in our system of fire, so we will change it through the blueprint. Sprite size is 0.5 by 2, so it's a little bit I actually forgot the word because I'm a little bit tired. Actually, I have the apartment renovation, so please forgive me. We actually need some bean kinds of shape. As for scale color, I have the curve on the alpha attribute. It's flowed from curve with 2 points. Scale curve is set to 1. Both points have tangent alignment set to auto. And embers should disappear when they are actually flying over our fire. We also have gravity force 200 on z-axis, so they are flying up, and curl noise force with a noise strength of 200. So actually it's some random rotation. As for sprite renderer, the alignment is velocity aligned, so the sparks are actually moving with some realistic behavior. And as you can see, it's a default sprite material because we don't need any changes here. Now let's talk about Niagara emitter of smoke. As for Niagara emitter of smoke, it's also CPU particle with the local space checkbox selected. Next, it's infinite, and we have the same loop delay behavior as we have in our embers. It's 0.75 the delay, and it delays only the first loop. The spawn rate is 6. The initialized particle lifetime is uniform range float with 2 different values. As for the color, I'll have some gray color and the alpha is 0.1, so it's actually a little bit transparent. The sprite size is less than our main sprite size of our fire. So the visual look is pretty much similar to the realistic one. As for scale color, it's the same behavior as for the Embers. 2 points. Scale alpha is float from curve. The tangent alignment is auto. We also have gravity force, the 25 on z-axis. And for sprite renderer, actually our smoke material and nothing here. Also make sure that Niagara emitter of fire in sprite renderer has the material instance fire. Now let's talk about Niagara system. As you can see, I have 3 emitters together. It's Niagara emitter of fire, of embers and smoke. And Niagara system has user parameters. It's embers color, fire color and smoke. To add user parameter, you need to press on the cross and select the proper type. For instance, if we talk about color, it can be linear color. Then you need to rename it to your purposes. For instance, test. And here you can see that we have the warning, so our parameter has been changed. Also, we need to check all our references that our variable had earlier. Now, let's go to initialize particle of fire and see that right now in color I have fire color user attribute. To change the default value, this one, we actually need to look for our custom attribute. Just like this. The same for Niagara emitter of Embers. It's also color. And Niagara emitter of smoke, it's also color. The same here. So right now we can actually change these attributes through our blueprint. So let's do it. I have created the blueprint. It's called BP_fireplace. It's actually the child that inherits from the BP interactable base class. Here I have the following setup: the static mesh for our fireplace and static mesh which handles our log. Let me show you. This one. As you remember from previous episodes about interactable objects, here in the interactable base class, on check components and proceed, where we actually check for the static mesh object to be the primitive component. So when we actually start interacting, there will be the outline, and whether it's valid, we also will have our widget shown so we can start interact. I have some changes because I don't need the whole object, the whole fireplace to be outlined. I only need the active element. In my case, it's the log. to fire the whole logic for our fireplace, I have made some changes in the interactable base class. So let me show you where check component and proceed custom event is fired. It's on the event begin play. We are checking whether our component has the tag. So right now we need to provide that tag. In my case it's in the interaction, and we are looking for all components we have in our blueprint here. Right now it's 2 components for the static mesh or for the skeletal mesh. It depends whether you use static mesh for your child or the skeletal mesh with some animations. And because you only need one element to be active, it will be the activator. So only this element should be outlined. You need to provide the tag for this element. So for the static mesh here, as you can see, I have no component tags, but for my log, it's the proper one with the proper name, interaction here. So as it is in our parent. So whether we have this element with the proper tag, we provide it to primitive component reference, and now the whole logic will actually continue. So we will have the outline and we will have the widget component activated. So if you don't look, or if you haven't seen the tutorial, please check my channel on interaction system. And if you have some questions, please direct mail me so I can help you with the implementation of this logic. Now, for the variables here, I have fire color, amber color, and smoke color exposed. So I have access to them through my scene. Here, the BP Fireplace is placed in my level, and I have amber fire colors, fire color, amber color, and smoke color exposed. And actually the interaction time, the time I need to interact or start interacting with the object, and the attribute active. It means whether I need the fireplace activated through right when the game launches, or whether it should be deactivated, so I actually need to activate it by myself. And the logic is pretty simple. We check whether we have the active element. Whether it's active, we need to activate it. Whether it's false, we need to deactivate it. And here we have Niagara particle system. Also make sure to check the proper transform attributes, so the whole components actually look realistic. As you can see, I have some changes in location, rotation. Also for my Niagara emitter, so it's the position where my emitter should appear. And as you can see, I have provided my Niagara system as the reference, so I don't need it to do in the construction script, and I use it as the reference to set color parameters with the proper name for each of element of emitters I have. For the Niagara emitter of fire, of embers, and smoke. and event main body, the co-event main body. So the first will trigger the logic from the parent class here, and then we have simple toggle for switching on and off our Niagara system. And actually that's all. And right now, as you saw from the demo in the beginning of the video, we have the fully walkable fireplace. I hope this tutorial was helpful, and it's a little bit relief for me, because the previous tutorial on minimap actually had some impact on my mental health. It was very complicated, almost 3 hours. So right now I'll do some lightweight tutorials. Also, it's Christmas time, so the winter is here, and my tutorials will be about some cozy stuff. But nevertheless, please stay tuned, leave your feedback, and subscribe if you like my videos. And see you soon!